All right, this lesson is on multiplying polynomials using Pascal's triangle. In this task, we'll be exploring patterns with multiplying a binomial by itself in a successive number of times. We'll explore Pascal's triangle and help you to do this. The following diagram is known as Pascal's triangle. Note how each row has one more element than the one above it. In fact, this pattern can go on indefinitely, and the next row is always from the row above it. So task 1, write down the next 3 rows of Pascal's triangle. So how the pattern works is if I look at 1 and 2, I get 3. Same thing here, 1 and 2, I get 3. 1 and 3, I get 4. 3 and 3, I get 6. 3 and 1, I get 4. So to continue the pattern, you have 1s on the outside, and now 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 1 plus 4 is 5. So that's the next row. Then you add 1s on the outside. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 15, 5 is 15. 5 plus 1 is 6. One more row. 1's on the outside. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And then 6 plus 1 is 7. So that's the pattern. Now we're going to go ahead to task 2. It says expand and simplify the following using the FOIL method when necessary. Be sure to collect the terms and rearrange the order in increasing power of 1. So the first example, A, says the binomial A plus B raised to the 0 power. Anything raised to the 0 power is just 1. Example B, A plus B raised to the first. Well, that's just itself, A plus B. Example C, A plus B. So what we have to do is we have to FOIL out those 2 binomials. So we do first, outside, inside, last. And we get A squared plus A times B plus A times B plus B squared, which simplifies to A squared plus 2AB plus B squared. The next one is now 3 binomials, A plus B, A plus B, A plus B. So we first need to FOIL the blue. Well, we already have that here. So that's A squared plus 2AB plus B squared. And then we multiply it to our binomial A plus B. And we get first, outside, inside, last of A squared times A, which is A cubed, A squared times B, A squared B. Then we go to 2A B times A, which is 2A squared B. We multiply 2A B squared, and then we distribute the B squared. And we get A B squared, and then B cubed. And then we need to put this in standard form and combine any like terms. So we have A cubed. These two terms are alike. They become 3a squared b. These two terms are alike. They become 3ab squared, and then b cubed. Now, Pascal's triangle is a method to help you with binomial coefficients when you have to multiply x plus 1 raised to some power, where n can be any positive integer and x and y can be any real numbers. Pascal's triangle is represented in a triangular form. It is a kind of a number pattern in the form of a triangular arrangement. It begins with the number 1 on the top and again runs down on the two sides. In Pascal's triangle, each number between the two numbers and below is the value of the sum of the two above, which we saw in task 1. So here is x plus 1 raised to the 0. Here's x plus 1 raised to the 1, which is x plus y. If we expand out x plus y all squared, we get that. And notice the coefficients are 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. This, you can go ahead and pause and read the properties of Pascal's triangle. Why do we need to know this? This is going to help us when we want to multiply with binomial expansion. There is a pattern, and this is the all-important pattern right here. So let's go ahead and do some examples. This is what you'll see in your practice today. Use Pascal's triangle to expand x plus y to the third. So I have a Pascal's triangle up to row 5. So first what we need to do is look at the degree here. It's going to be expanded. So then we go to this row of 1, 3, 3, 1. And now we start off. So I'm going to just go ahead and write 1, 3, 3, 1 is my row. And now those are going to be my coefficients. So my coefficient is 1, and then I choose the first term x, and I raise it to the power of 3. The second term is my y term. So that will go to the 0 power. So just kind of bear with me and I'll show you the pattern. Then I do my coefficient next from my Pascal's triangle, my x, and now I drop that degree by 1, and then I go y. Now I increase my y to the first. Then I go to my coefficient from Pascal's triangle, 3, x, and now I drop the degree by 1. And I increase the y variable. And I have my coefficient of 1. I drop my degree by 1. Then I increase my degree by 1. Notice that the x term and the y term, those exponents will always be the same number when I add them together. They're all going to be 3's. Now we have to simplify. So we have 1 x cubed, and then this y to the 0 is also a 1, plus 3 x squared y plus 3 x y squared plus 1 times 1 y cubed. So then to finish it, we have x cubed plus 3x squared y plus 3x y squared plus y cubed. Example 2. We have another binomial expansion, power of 3. So that'll be our Pascal's triangle coefficients, 1, 3, 3, 1. So our first coefficient is 1. Our variable is x. Raise it to the third power. And then our second term is 2. So that's 2 to the 0 power. Then we put our coefficient of 3 from Pascal's triangle, x, and now we drop a degree, and then increase a degree. Plus 3 x to the first 2 squared plus 1 x to the 0 2 to the third. And now we simplify. So I'm going to simplify the numbers. So I have 1. Anything raised to the 0 power is 1, and then x cubed. Then I have plus 3. 2 to the first is 2, x squared. Then I have 3. 2 to the squared is 4, x to the first. Then I have plus 1. 2 to the third is 8. X to the first, x to the 0 is 1. And then simplify. 1 times 1 is 1, x cubed. 3 times 2 is 6, x squared. 3 times 4 is 12, x. 1 times 8 times 1 is 8. All right, last example. Now notice our power is 4, so we're going to go to the next row in Pascal's triangle, and those will be our coefficients. So 1, 4, 6, 4, 1. So our coefficient is 1. Our first term is 3x, so that's going to be 3x to the 4th. And then we have a 2 to the 0 plus 4, 3x to the third. So again, you're dropping that blue term by 1, and then you're increasing the green term by 1. Plus 6, 3x all squared two squared plus 4, 3x to the first, 2 to the third, plus 1, 3x to the 0, 2 to the fourth. So those are all the terms, and now we have to do some simplifying. So we have 1, and then 3 to the 4th power is 81. 2 to the 0 power is 1. And then x to the 4th power is x to the 4th. Then we have 4. 3 to the 3rd is 27. 2 to the 1st is 2. And then x cubed. Go to the next term, 6. 3 squared is 9. 2 squared is 4. And then x squared. Plus 4. 3 to the 1st is 3. 2 cubed is 8. X to the 1st is x. Plus 1. Anything raised to the 0 power is 1. 2 to the 4th is 16. Then we multiply again. 1 times 81 times 1 is 81, and then x to the 4th. 4 times 27 times 2 is 216, x cubed, and then 6 times 9 times 4 is 216, x squared. 4 times 3 times 8 is 96x. 1 times 1 times 16 is 16. Now this problem, we have one more step to do. If we look back at the first two examples, notice that the operation between them is addition. So all of the terms when we multiply are going to be positive signs. If we look at the second example, the operation between them is addition. So when we multiply, no sign changes. The polynomial, all positives. What's different about this example is we are subtracting. So what I tell my students to do is just to sign change. So the first is positive, and then we change this term to a negative, and then keep the positive, and then change this term to a negative. So we have sign changes. We go from a positive to a negative to a positive to a negative to a positive. That's what happens when you have a subtraction of that binomial.